Hi, can you guys hear me?
Hi, can you guys hear me?
Cool, just give me like 2 seconds to finish setting something up. um, um, Mookie's literally right here. Get off. All right, so I think it's all set up. This is really annoying. Mookie's right here. All right, so particular, this is going to be really annoying to keep up with, but particular topics, questions, sample question you want to see. Let's hear it. You can't do live from a screen record. If I did it on my laptop, you'd only be able to use the front-facing camera. Particular like topic, sample question, I don't know. Question. So remember another thing that we discussed, some questions like this might say round to nearest tenth. And that usually implies kind of like the same thing that I said, simplest radical form. It's implying that this isn't going to work out nicely. You could do CTS, and some people, just like where people do quad formula on a factorable. CTS will work on something that factors, but since I'm saying radical form, you could probably assume this isn't going to work out nicely. Do you have to have the y-intercept of the parabola to make a quadratic equation? No. If you're doing it by hand, that makes it very, very helpful. Technically, you need any 3 points on the quadratic, so it doesn't necessarily have to be the y-intercept. You could do a quad regression with any 3 points. If you're doing it by hand, I would usually always give the y-intercept, just because that's pretty much giving you the c value. Which questions do kids trip up on? What questions do... Just in general, which questions do people trip on? Hopefully nothing tomorrow. But in general, where people lose a point or two, like if someone asks this in the Google sheet, usually conversion questions or something where there's a unit change, something that, I might not even catch reading it the first time through. Something that, we call it a trick for a reason. I don't know where it's going to be tomorrow. Could be like we saw in the mock test where they change the scale. Could be something where they say inches and then feet. We saw one in the practice regions where they said radius and then the question said diameter. So things like that. Okay. All right. So if we're doing this for using CTS, what would I do first? What would I do first? I have no idea. Move the 3 over. Very good. The lunch regions. I'm not Mr. Andak, so no, I do not have the review sheet for that. Next, we're going to add that number to both sides. That's going to make it a nice perfect trinomial. In this case, that magic number, I put a box just to kind of show or emphasize that I'm adding it. What would that number be in this case? 49, very good. A lot of people forget to add that to both sides. That's usually where you get tripped up on a multiple choice. Okay, and now we can write this as a bubble squared. That was the whole point. And it's going to be x plus 7 squared. On the right, if you just do that addition, it's going to be 46. A useful little trick, that's always going to be half. Okay, if you think about that, if we were to FOIL it out, we have 7x twice. So it's always going to be a 2-to-1 relationship. Okay, now, how do you actually solve this from here? Once we have something squared, obviously we wouldn't want to FOIL it out. We'd get exactly what we just started with. We'd get x plus 7. We don't want to forget when we take the square root of something, there's both a positive and a negative, so plus or minus 46. Move the 7 over. And it did say simplest radical form. Usually they don't go too nuts with this. It's something like radical 8 or radical 12 that you could easily pull something out. But in this case, nothing does go into 46 that we could factor. 46 is just simply 23 and 2. So that would be as simple as it gets. If it did say nearest 10th, be careful. You would have to enter this in separately. And I have to get my calculator out. I'm not sure what this is. Okay, you'd want to enter one in where you're adding and one in where you're subtracting. Just be careful with rounding with something like this. Okay, other topics. Rearranging formulas. Oh, okay, rearranging formulas. Rearranging formulas. I like that. 20% battery. All right. I have to get a charger. Let me get a good formula here. My phone's on 20%, so stay with me here. Yeah, I mean, the classic ones that they ask, sometimes they just literally make up their own formula or their own equation, but usually they use geometry ones. I mean, you've seen the volume one a lot. I kind of like when they did, some of you guys saw this, that asked for extra practice stuff. Let's try this. Kind of do a split screen here. That is like the printer I have on my desk. I don't know what that noise is. So, does anyone recognize that formula? No one recognizes that formula. Yeah, it's arithmetic formula. Okay. It's the explicit arithmetic. Very good. So two different, obviously we could solve for A1 as well, but that would be kind of easy. I just have to subtract that whole second half. So if I wanted to solve for D, which in this case is the common difference, I don't care about any of that. This is just practicing if you know how to rearrange things, how to move things around. Okay. The first thing I would do is subtract A1 for both sides. And I have this. Okay. And we'll do N in a second. Now, if I want to solve for D, this is where you sometimes get confused because you're so used to, hey, there's something outside, let me distribute. But if I distribute here, I'm going to get dn minus d. So I'm making it kind of more complex. In this case, my next best move would be to divide by n minus 1. And I'm actually done right there. Okay, that's solved for d. So now let's start it again, but if we solve for n, so we're going to start off the same way. We're going to subtract a1 from both sides. What's that? Okay, and obviously it's going to change right here. So now I want to get that n by itself. Once again, I don't want to distribute and make it more complicated. Let me get rid of the d here by dividing. And now I have an minus a1 over d equals n minus 1. Going on to the second page here. So now all I have to do is move that 1 over by obviously just doing plus 1. And that's it. So with rearranging formulas, just be careful. Always think about the inverse. I know the one that we had trouble with on the mock Regents. Let me pull that up quickly. The variable was in the denominator, and I think a lot of people got confused with that. I just want to pull that up. Okay, so I'm gonna make my own thing up here, but it's something like this. This is really not a formula. Okay, and it said solve for A. Yeah, there's no humidity questions tomorrow. Yeah, actually, a really good point for the people. I know not everyone's in here, but it seems like a good chunk of you are in here. Let me just go over that quickly. I see some of you guys are asking that. With pens and pencils. This is actually very, very important. Pens have to be used for every written question except for graphs. Now, you might be saying, why? Like, who cares? Let me just do a graph. Think about if you do a graph in pen, you make a mistake. Okay, you can't just say, can I have another test booklet? Okay, for one reason, there's literally only an exact number of test booklets. You don't want to cross it out and make it look, you can't use whiteout and things like that. So pencils are used for graphs, like diagrams. If there is like a weird chart or something, you can use pencils. This way, you don't really have extra space or extra graphs to do something in. If you make a mistake for a non-graphing portion, you have plenty of room. They usually give you like a full page for a written question where you only need a little bit. So you just put like a slash through it. Bring pens and pencils, yes. You cannot use a pencil for everything. Every written question needs to be done in pen. If you do it in pencil, you have to trace it over. You could use pencils for the Scantron and graphs. Pens for the written questions. Rational tangles, that won't be on the test. Okay, so if we wanted to solve for A, I'm not proctoring you guys tomorrow. I have you guys both magnets in the morning, which is why I'm able to do the review sessions. I'm off period 4, so I might stop in just to make sure everyone's set up with supplies. But other than that, I'm not proctoring the test. Okay, so if we were solving for A, what would you do first if you were solving for A? This is where a lot of people lost points. This is a 2-point question on the mock. So it's kind of like the thing you want to solve for is stuck in the denominator. The first thing you would do here, multiplying by 1 over mln, whoever said that, the a squared would still be stuck in the bottom. So the first thing you're going to do here is actually multiply by a squared. Okay, that's going to get rid of it on the right. And on the left, now at least my a is not trapped in a denominator any longer. Okay, now I could divide by s. So basically the s and the a squared kind of switch places. Everyone see that? So I had to multiply by a squared first. I kind of got it out from being trapped in the denominator. And now what can I do? Then now I could take the square root and just leave it like that. You might want to consider plus and minus. I know the one that was on the mock just said positive, so they kind of eliminated the plus and minus symbol from being confused at all. But anytime you take a square root, think about plus and minus. You do not need to label piecewise functions if it's just one. Nope, nope, nope. Domain and range. All right, domain and range. Domain and range in what context? Please do statistics. There was a train he was eating. The heck? Domain like number 24 on the June 2015. Mookie dipped out. I don't know where he went. $30 on the June 2014. Okay. Yeah, so that's easy. So domain, the important thing to know is that this is associated with input values. Oops, good spelling. Input values such as x for like a regular function f of x. And range is associated with output values. So if our example is f of x, these would be our f of x, our outputs. Transformation rules. So for example, if I have a set of points, I don't know, something like this. Your domain would be just the x values, whereas the range would just be the corresponding y values. Okay, domain and range. If you're asked for a graph domain, you're looking, so remember it is X, you're looking left to right. Sometimes it might just give you a picture, I'm saying. So look at, hey, what's the furthest left it goes? What's the furthest right it goes? Okay, for most functions, the domain is all real numbers. For things like square root functions, obviously there's a cutoff. For range, you're looking up and down vertically. We know for quadratics, they don't have an infinite range. They have eventually a point where it cusp around. The turning point, the vertex, is that deciding factor. All right, next topic. Just give me 1 second. The SHSAT isn't gone yet. That's an idea. Whoever said that, it's not official. And what's my battery life on this thing? Let me get a charger. All right. I'm gonna try to set up a problem, and then I have to get a charger. Technical difficulties here. Sequences, recursive. Okay, so let me set one up. I have to go run downstairs to get something anyway. See if you guys could do this. Sequences and graph inequality. Do the random topics. The reference sheet's in the booklet itself. Remember I said that's the first thing you should rip out. I yelled at your proctors today, first period. They're going to remind you that as well. So let's say A1 is -5. Okay, so this is a recursive sequence where we're told the first term and the relationship between future terms. Let's try that out. Take a minute or two. I'll be right back. Mookie doesn't know how to use an iPad. Alright. Charger. What's up, Mook? Miss Marley, please. All right, so let's take a look. So recursive sequences people usually have a little bit trouble with, just because explicits are usually a little bit easier. You can just simply plug in whatever you need. With recursive, it's kind of like a puzzle. You need each piece along the way. So obviously I have to tell you something here. I'm out of breath from running. I tell you the first term. What we're looking at here, remember this relationship, some people get confused. Well, that just means, hey, if I want to find the next term, I use the previous one. So in other words, if I need the fifth term, I gotta find the fourth, the third, the second, etc. And sometimes it's easier to think about this in words. So what is this saying in words? Multiply the previous term by 3 and add 2. So if I do that to -5, I'll get -13. Sorry, this is on an angle. Yeah, we were working on humidity so far. Yeah, that would be the same. Whoever asked that would be the same. Swift, whatever your name is. A3 would be -39 plus 2, that would be -37. A4 would be, it's getting a little bit larger than I would have liked, but what is that? -111 plus 2 is -109. And the fifth term, what we ultimately want, double check my math there, 90 plus 21. Yeah. And then 3 times -109 plus 2 is -327. Plus the 2 is -325. So not that you have to show every step here. You know, you could obviously do it a little bit more informally, so maybe just in your calculator, typing these, and then using like A4 for your last one, but this is what it really looks like. And if you look here, this is where the recursive nature comes in. See this kind of chain effect happening? Graph inequalities in standard form. Okay, that's a good, if I had to predict, and I don't like predicting, but I could see an inequality for, I have a feeling of inequality for number 37. They haven't done that in a little while. Which Regents did that appear on? Nope, not that one. Okay, this one, yeah. That's not an answer key. So I know we didn't get a chance to go over the June 2015. Someone asked about inequalities. I'll kind of use, for people that did the June 2015, this was number 35. Okay. So these, this is why I'm saying I could picture that even though this was a 4-pointer, they usually like to ask these as a 7-pointer. What? You know, like I said, I could see this tomorrow. I don't know. We'll see. But this usually involves translating at first in the beginning. So in this case, we're looking for inequality vocab words like at least and maximum that we see here. Ultimately, I arrive at this as my system of inequalities. We know it's a system. I got 2 of them, and it's inequalities, not equations. Okay, and this is where we really get into the graphing with inequalities. One option we could do, I could get both of these in Y form. Okay, and then I can do things like M and B to graph this. However, with inequalities, you guys know I've taught you this in the past, it's a little bit to your benefit to graph it just using the intercepts. Okay? The intercepts are found by kind of like pretending the other variable isn't there, because you're setting it equal to 0. For example, if I wanted to find the x-intercept, y is 0. Okay, what is the x-intercept? 15. Obviously, it's going to be the same thing for y. So that's how for that top function, I got 15 and 15. Okay, for the bottom one, you might have to do a little bit more solving. Okay, once again, the x-intercept will be where y equals 0. So if I plug in a 0 for y, now I'd have to solve this. 2,500 divided by 50. I get 50. And I'm going to get 5 for the y-intercept. So I like this. You only have to find, or you're plotting 2 points for each one, or 4 points altogether. Y also works nicely because you have one quadrant. Okay? It's also a good reminder, you will lose points for these if you do this. Can anyone tell me why you will lose points if you put arrows on these? Yeah, this would be a negative, okay? So my point is with the intercepts, if you just plot the points, is also kind of reinforcing that. Whereas if you do M and B, maybe put an arrow, I don't know. All of the other rules still apply. Solid line shading below here, solid line shading above. Sometimes they might say label with an S. If they don't say anything, I just labeled where they actually overlap. I didn't even bother labeling like the non-overlap sections. You also notice on this Regents, they changed their mind a lot. This one they happen to label. Okay, if they didn't put that there, you would have to. And if you don't, they do take off for that. So make sure your axes are labeled, specifically with word problems. If it's just graphing a normal function, obviously we don't give it a random name. But if it's some context or something there, it can't hurt to label it. If you're ever in doubt tomorrow, it's better to do something and not need it than, hey, I didn't do it, I didn't think I had to, and all of a sudden they take away 1. They're not going to take away 1 because you did, too much of something. And remember, with inequalities, we're looking for where both shadings overlap, and then there's usually a follow-up, hey, pick one, or sometimes they say, like, is this person correct? So, like, hey, they said this, were they correct? No, it's not in the shaded region, if you're asked to explain. Or yes, it satisfies both inequalities, if you're asked to explain. The humidity joke is old. Yeah, it is old. Adjustment functions. Okay. Adjustment functions. What do you mean by adjustment functions? Do you mean like giving you one and then which ones are equivalent? Do you mean like, can you be more specific? Like write something, stick around even. Don't worry about writing a quadratic formula solver program. That would be like number 10,000 on my list of things to worry about for tomorrow. Equivalence, okay. So Allison asked for this type of, and this was the most common incorrect multiple choice on the mock. These ideas of like, hey, which of these are equivalent? A lot of you guys, there's backdoor ways of answering this where you just type them in and see what works out. Obviously, you might want to answer it a little bit more efficiently. We'll do a few of these. There's different versions. Let's say. Oops, sorry. Not on the screen. Okay, so that's one we'll work on. We'll do something with that in a second. We'll do that in a second. Okay. So you can kind of see this kind of looks like an exponential model, maybe of growth or something, but our exponent here actually says x plus 2. Okay, and this would be a multiple choice, let's just say, or maybe written where they say like, hey, someone else wrote this. Are they the same? We actually saw that on one Regents in the past. But let's pretend this was multiple choice and you had 4 other functions. A lot of you guys just typed all 5 of them in and saw what worked or what didn't work. How you're actually doing this is actually applying exponent rules. Okay, if we look here, 2 exponents were added together. So if we decompose that, if we break that apart, what had to happen for 2 exponents to be added? They had to have the same base. So in this case, the base is 1.05, and those individual exponents. So look at that. This would be equivalent. If that was a choice, okay, that would be your answer. What? Who's Matthew? All right. So anyway, I would focus more on these guys than people are being a little silly in here. I could take this a step further. If you look, the exponent all the way on the right, I could actually evaluate that. Okay, this is a number. So another way for me to write this, that actually works out if you type in your calculator to 1.1025. This I'm never going to be able to get rid of. It's an exponent of x. And now I can multiply that by 2,000 and get 2205. This would probably be the choice, that would be like, hey, which of these were equivalent? I'd say the answer on all the way in the bottom. And the long way of doing it, not the long way, but kind of the more efficient way of figuring out is what we just went over. Hey, you can break it apart, because what's your rule with exponents if they have the same base? I don't know why I wrote it like that. If they have the same base, you can add the exponents. So if we think of that in reverse, hey, we had this to start, we can break it up as 2 different, or 2 of the same base with those 2 individual different exponents. And now I just evaluated, if you're curious, like where did this come from? It's me just evaluating that purple number. Okay, and the one on the bottom, what can I do here? So that's a double exponent. I could think of it as a double exponent. So we don't have a sum here. I can't break that up to like 2 to the third times 2 to the x. However, I could do this. Can anyone tell me why I'm allowed to do that? Am I allowed to do that? Grasshopper review. Who's Matthew Photo? Are there people from other classes in here? Yeah. So this rule is the second kind of exponent rule here, which I call, not formally, but kind of the double exponent rule of this. Like, hey, if you have something multiplied, you can break that apart. Or going this way, if you have them like this, an exponent raised to a second exponent, you can multiply. So if we break this apart and kind of slide this 3 in here, and it's still equivalent, so it's still good as of now. And now what can I do with 2 to the third? I could think of that as 8. Okay. So 2 rules to be familiar with. Like I said, are there other ways to answer these without actually knowing the rules of, hey, add the exponents when you're multiplying or multiply the exponents when you have the double? Sure. Calculator, guess and check, plugging numbers in. This is kind of actually what's going on. And note here, I can't make this like 400. Okay, I'm not allowed to do the 50 times the 8. This has an exponent attached. So, what was the grasshopper question? August? I'm just going to pull out my answer key. Da, da, da. Was this on August? Yeah. Oh, and this is only a 2-point question. So if whoever asked this is being serious, here's the grasshopper question. Okay. Rice doesn't know. What? Rice doesn't know how to do the grasshopper one? True, I don't. So this was one where we're requiring, and I'll show you guys because it's the actual booklet. Get scrap paper. Most people don't use that. But then you get this. And if you notice here, like tomorrow, you're going to be able to tear this out of your booklet. It's like perforated. It's kind of like pre-cut. Okay? The formulas that you guys are going to use on this sheet tomorrow literally will look exactly like this. Just these three. This is geometry, 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 algebra 2, Pythagorean theorem, I guess geometry, and everything in there is obviously literally a geometry formula. Possibly, maybe use one of these if they don't. Usually in a rearranging formula question, they give it to you, but I guess you could reference that if you want. And the other things you might need to use are up here. Just kind of new the past year or two. They started utilizing these, I guess maybe because they realized they're not using them in any other questions. So this grasshopper one talks about, I think, kilometers and miles. So I pulled that right off that reference sheet. Okay, or inches a mile, sorry. So this was a proportion at first. Hey, if you could jump like a grasshopper can jump. So a grasshopper, I figured out, can basically jump 20 times its size. 2 out of 40, which I simplified obviously to make it a little bit easier to work with. 1 out of 20. Okay, where did 69 inches come from? That would be someone that's 5'9". 5 feet is 60 inches plus the 9. Okay, now if we think of this times 20, so once again, we said, hey, if someone's times 20 or can jump 20 times their height, like the grasshopper, obviously this is very unrealistic. But if you could, that would be a total of 1,380 inches. Okay. Now, how many jumps would that take you to jump, 1 mile? So 1 mile, I mean, this one you didn't even really need the chart, to be honest. Most people, I would say, know that. People that run track know that. 5,280 feet are in a mile. Okay. And now I'm dividing that to figure out how many times or how many jumps. And then I converted the 5,280 to inches by multiplying it. How many inches are in each foot? 12. So I multiply that by 12, and then I divide. Basically, like, hey, this is each jump. This is how far I have to go altogether. How many do I have to do? And be careful with the phrasing of the question. This is one of the, someone asked earlier, like tricks. This could be something nearest jump. So 46 jumps was the answer for the grasshopper. Yeah, for people that weren't here earlier, questions tomorrow, all in pen. The only thing, I'll use this Regents as an example. So this would be pen, pen, pen. This you could do in pencil technically. It's a chart, it's a table. And then obviously any type of graph. So graph right here, pencil. The work on the side, pen. You know, doing stuff up here, pen. But when you're on the actual graph paper, you could use pencil. So let's say I make a mistake, okay, I could obviously erase it versus they don't want to see this all over your paper. So pencils just for the graphs and your multiple choice bubbles. When you're actually working on the multiple choice questions, it doesn't matter. No one even looks at that. So I would say whatever you're more comfortable with. Obviously, the multiple choice doesn't have a lot of space, so if you want to use pencil, this way you can kind of clear out space. I would recommend that, I guess, but this honestly doesn't matter. No one will look at this ever, literally. What matters is what you bubble in, just like with one of my tests. Yeah, there's no teamwork on the Regents. People that do teamwork are taking the August Regents. All right. I wouldn't recommend for the part twos doing it in pencil first, because then you literally have to write over it, and that's going to take away time that you could have spent checking it. So yeah, some people ask, like, can I do it first in pencil and write over it? Think about how much time that's going to take, where you could have been checking stuff over. Statistics, all right. What with statistics? Regression, oh geez. Okay. Correlation and regression. So the first thing, obviously you guys receive calculators tomorrow. We actually, the whole math department today actually spent time. Diagnostics were turned on every single one. So if you want to be, careful and just do it yourself again, that's fine. But literally the calculator you receive tomorrow, diagnostics will already be turned on. So you're good to go in terms of that. I guess we'll reference one. I can't kind of make up a regression question. I guess I could. Yeah, let's make one up. Now my laptop's dying. All right. So let's make up our own data. I don't even know how this is going to work. Let's say the number of hours that someone studied versus their Regents score. And let's say I surveyed 6 people. 1, 2, 3, 4. Doesn't study gets 100. So let's say someone studied 2.5 hours. They got I'm making stuff up as we go here. Someone studied 1 hour, they got a 90. Someone started 0 hours, they got a 85. Let me change this actually. Someone studied 5 hours, they got 99. Someone studied for a half hour, they got a 88. And someone studied for 2 hours and they got a 89. No. What do I want that to be? 92. Okay, so take a second if you have a calculator on you. Let's do the correlation. And let's call this the line of best fit. Linear regression, if we want to be fancy. Let's say every decimal to the nearest hundredth. All decimals to the nearest hundredth. Why did no one get 100? If 723 gets 5 100ths, you don't have a calculator at home, dude? If 723 gets 5 100ths, I don't know. What will I do? Oh. Where 2 2? If in 723 alone you get 5, in 723 alone if you get 5, I will do that. No, no high heels. I'll wear I don't know. I'll wear something. Lipstick, eyeliner, no. BTS shirt? Yeah, I'll wear a BTS shirt. Wow, that's all I had to do to motivate people to study? No short shorts. This is Mookie. If we get hundreds, give us Regents answers. Mookie's the GOAT. All right. For next year, the Regents answers. All right. So, I gotta do this problem myself, actually. My battery's almost dead. So, when you type, can you? Oh, cool. That comes out kind of clear. When you type in, remember hit stat to go into your list. I'm just gonna type it in myself. Be careful when you're typing in. We saw that 1 year. I can't remember it off the top of my head. I believe they said like the year 2007, and they said like, oh, qual 2007, year 0. So just be careful. Sometimes we just look at tables and we don't read the directions. Just make sure you're reading it. Okay, now we're gonna hit stat. It's hard to do both. Calc and linreg. Hopefully my diagnostics are on. I didn't check. Yeah, they are. Okay, so if everything's to the nearest hundredth, this would be 2.61x plus 86.38. And our value is 0.99. Whoa, pretty good for made up numbers. So what does that mean now in context? We love that question. What does this mean in context? Can Mookie be our teacher? He's not very smart. Takes after me. What does this mean in context? There's a strong positive relationship. Be careful. That's not in context stuff. You just say between x and y. Context means I want to add this to the equation. No pun intended. Okay? You would obviously say strong and positive, but me saying the words in context mean I want to reference, hey, the more hours you study, as your hours go up, hopefully this was common sense before even doing this, the higher your more hours, the higher your score, or vice versa. The less hours, the lower your score, in general. Okay, remember anytime you're doing regressions, modeling something, it's a suggested fit. Okay, it doesn't mean, someone could have studied for 0 hours and got 100. This just means in general, this is what's going on. However, we can see this is a pretty strong, very, very strong relationship. But in general, this is what happens. Now, one thing I want to go over, because some people are still confused with this. Can you guys tell me the difference between a linear function and an exponential function? What's the difference between a linear function and the exponential function? Don't say constant growth rate. That would actually be on the other side. Linear has a constant rate of change. I believe Jacqueline said that. Constant rate of change. Good. Now, what does that really mean? Sometimes we say it and we have no idea what that means. We're either adding or taking away. Okay, when we're taking something away, you're adding a negative. The same numbers over and over again. Now, exponential, we know what, those word problems, hey, 2% growth, you open a bank account, blah, 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 blah. But exponential is really a constant of multiplication. When we say percents, you're multiplying, right? When I say, hey, I have a 5% bank account, that's really multiplying by 1.05. So multiplying by something over and over again. So these would be equal differences, adding or taking away. I saw that as a choice one year. And this would be equal factors. Okay, I'm multiplying by something, or vice versa if I'm working backwards, like dividing by something. So be careful. Sometimes we kind of associate that incorrectly. You just see the word constant and you get happy. You're like, oh, linear. Anything with the word constant is linear. Exponential is also constant, just in a different way. Like how you're multiplying by 2 over and over again. It's constant if you look at it that way. Okay, let's do a... Like everything's dying here. Let's do a quad... Give me 1 second. Let's do a quad word problem. Okay. So let's say I throw something in the air. Oh, you know what? Oh, I totally forgot about this. I had a bunch of practice questions. What school do you go to? MS 74. All right, my battery is dying still. All right, I want everyone to try this. This is gonna take you a little while. Take out some scrap paper. You see that, kind of? Try that. So vertex form, if you do need a little hint, vertex form, the generic version, looks like this, where HK is your vertex. So try that. I'm senior, Curtis. Okay, charger. Which one on the June 2015, bud? $32? All right, we'll check out 32 after this. Review. All right, so let's go through this. So this is obviously going to involve CTS, okay? And notice we can't cheat here. What do I mean when I say cheat? Sometimes you could just find the vertex and simply plug it in, but the question might say something like use, an algebraic process. In this case, it says CTS. So I actually want to show my work. I can't just cheat. Okay, and also when you do cheat, in this case, it would be wrong as well, because while the vertex might be right, your value in front might be off. All right, so the first thing we're going to do here, when you use CTS, what's one of the first conditions? For you to use CTS, what has to be true? A has to be 1. So I'm going to divide everybody by -1. Okay, now that's going to make that negative f of x. I'm just going to change everyone's sign. It's going to become -8 of x and +10. I'm going to move the 10 over. We always do that. We get rid of the constant. Now in this case, the magic number that we're going to add is going to be half of b. Just ignore the sign. You're going to be squaring it anyway. Half of b is 4. If you square it, you get 16. So I'm going to add 16 to both sides. The pen is like skipping for some reason. Okay, that's going to be, I'm just going to simplify this. That's going to be plus 6. That's going to be x minus 4 squared. Remember what I told you guys earlier? When I told you about the whole year, that's always going to be half. And now, we're not solving anything here. Sometimes you get confused with that, like, oh, we take the square roots. We leave it like that. We're not actually solving anything. We just wanted to get that bubble squared. So now I'm going to move it back into place so that it says f of x. I kind of had to move like stuff out of the way, and now I'm moving it back into position. So I'm going to subtract the 6. And what's the last step? I'm not done yet. Kind of have to undo that very first thing, that negative sign. So be careful. The negative sign simply goes in front of the bubble. It can't distribute into the bubble. I can't make that like 4 minus x or negative x plus 4. I can't distribute that in right here. Do you see why? That would be breaking PEMDAS. I'd be dividing or multiplying before I evaluated an exponent. So simply just put the negative 1 in front, dividing by negative 1, multiplying by negative 1, the same thing. So it's easier just to put it as multiplication. The 6 does, however, change to positive 6. So now looking at this, where's the actual vertex? Can anyone tell me what the vertex is? Do a harder one. This was a hard one. 4, 6, incorrect. Need parentheses when you state the vertex. 4, 6 because of IHOP. Don't say 4 over 6. Okay, it's 4, 6, IHOP. That minus 4 actually means 4 to the right, or positive 4, and the plus 6 is obviously just plus 6. Now the negative sign does tell us that this is a quote-unquote sad face parabola. So in this case, the vertex would represent a maximum, a peak, a high point. IHOP actually changed its, this is probably the weirdest thing, I don't know if anyone saw this in the news. IHOP changed its names today. Yeah. Like, can't use I have to teach a different trick next year. You cannot use the quadratic formula for this. If I asked you to find the roots of it, if I said, hey, find the roots, where does this hit 0? You could do quad formula or CTS. We weren't solving anything here. The only way to go from standard form to vertex form is by CTS. Quadratic formula is a solving process. CTS is a solving process as well, but it's also a transition process. It helps us write something different. Okay, so let's try another one. Someone asked for inequalities earlier, I think. So we saw a few like this. It's not just, hey, solve this. It says determine the smallest integer that makes that true. Let's try that for a moment. J-Ho. Oh, Enzo, I got you, bro. Which one? Pamana, stop flirting. 32. Okay, yeah, this was a good one. This was actually in our... This is actually in our... You're excused. This was actually in our quad formula... I don't know what we want to call that. I don't know, quad word problem packet. And so we're dealing with, what is this? Such that the width is half of the length. And the area is this. Okay, so it's a rectangular. So right away, I'll write down this as a reminder. Hey, that sounds silly, but that's how I find area of a rectangle. And I'm given this relationship. There's a 2-to-1 relationship between the width and the length. They have to give me something else because obviously I couldn't solve it as is. So the width is half the length. Or in other words, if I multiply W by 2, I'll get the L. Or I could do L times 1/2 equals W. Okay? That's going to be important for substitution purposes. Because now when I write this, like I said, I wouldn't be able to solve this as is. Right? I don't have enough information. Maybe they give me a system and they tell me the perimeter, then I could do something. But I can't just solve that. It could be 34 and 1, it could be a really narrow garden, it could be 17 and 2. So it's important that they told us this. Like I said, you could write that, a bunch of different ways. You can call that 1/2 L equals W. But now what can I do with this? I could substitute. So I'm going to replace L with 2W. I get 2W squared. So technically this, believe it or not, is a quadratic. It does have a squared term. It's a really easy quadratic. Don't do the quad formula here for my sanity purposes. What little remains. All you have to do here is square roots. Just take the square root. And can anyone? My calculator is over here. Take the square root of 17. What does question say? Nearest 1/10 of a foot. So this would be 4.1. 4.1 feet were those units? Yeah. Okay. I'll show you my answer because I know I did it differently. And this is a good example. Pay attention close, guys. Watch if you did it differently. So if you called it x and x over 2, or like I said, that alternative, watch what happens. When you solve it, you get this. So you might have said, hey, the answer is 8.2. But if you set it up like this, 8.2 was actually your length. This question specifically just wanted the width. So this would be not much of a trick, but something where you could get caught a little bit. Just because, not that there's anything wrong with how this one was set up, but they wanted the width. They don't really care about the length in this case. All right, did that help? Answer number 32, whoever asked that, Enzo. Hopefully. All right, where's the other one I just had? All right, let's try this. Let's go back to this one. So solve this. Tell me the smallest integer that will make that true. Try this on your own for a moment. Mookie. All right, we ready? Oh, jeez. I'm sitting charge. All right, so let's solve this. Let's see what happens. I am sitting on the floor. That's usually where chargers are. Do you have chargers in your ceiling? Okay, so I would combine like terms here first. It's a very easy question, but like a weird follow-up is where I might have got some of you guys. Divide by -7. I get x is, what happens to that sign there? I divided by a negative, so it does have to flip. And now the question said, what's the smallest integer that makes this true? So it has to be an integer, so we can't play around with decimals. -4 does not make it true. Right? The answer to this would be -3. It's the next integer up. -4 would work if it was or equal to. The answer is -3. You need to be at school tomorrow by, I sent home like 5 people path messages about this, but in case you didn't get it, some people are coming at 8 a.m. Okay? You'll be in the auditorium. I'll be standing by like the doors. Some people might filter in a little bit later. For people not coming, the latest you could get there is 10:30. You're also going to go right into the auditorium. You're then going to be directed to your classes. 722 I know is in my room. 723. Mr. Arnell is going to go over all this tomorrow, but it should be in room. Does anyone remember from what I sent? I think 317. Okay. 10:30 is the latest, meaning it's not like, hey, let me show up, 11 o'clock. You might actually miss the Regents, and unfortunately, you'd have to take it in August. 10:30 is the latest. I would recommend probably shooting to get there by 10 a.m. You just go to the auditorium. I'll probably still be finishing up with the people that came early. And if you missed all the messages from the previous week, yeah, you can come in at 8 a.m. I'll be there. I'm off, so I'm going to be conducting. I know around 30 people have filled out that they're coming tomorrow. We're just going to be doing kind of like this, some last minute questions. If you come at 9, I'm going to be in the auditorium as well. Auditorium. In terms of what you need to bring, these are like in order of importance, pen and pencils. Okay, you literally don't bring your calculator. You're not going to be allowed to use it, and you run the risk of losing it. You're going to have to put it like on a shelf or something, and it might get lost, so literally don't even bring it. I bring like a little pencil case just to hold all these things. If you have like an eraser, not that you really use highlighters and stuff, but pencil case couldn't hurt. You'll be given a ruler, so you don't need to bring that. And then someone asks snacks, I would just bring like mints and candy. You can't pull out like an egg sandwich in the middle of the test. It is 3 hours. You're not allowed to leave during it. You're not allowed to eat like a hearty meal during it. So I would recommend eating a breakfast. You can bring water as well. You can eat food before, yes. And you're literally not allowed to leave. This is very important. Mr. Arnell was very strict with this. We're basically starting the test earlier, meaning that you can't leave before 2 o'clock. Across New York State, they administer it at 1 p.m., I believe, which means the deadline for the test is at 2. So if we start at 11, it ends perfectly at 2 o'clock, but you're not allowed to leave the building at 2 o'clock, until 2 o'clock. So literally, even if you do finish, you want to hand it in, your teacher's not going to let you out of the room until 2. You're going to be in the auditorium, so I would eat before you get to school. You're not allowed to eat in the auditorium. Or you could eat like in the alley outside of the school, the little walkway, I guess. All right. Let's try this one. we're starting earlier because if we started at 1 and it's a 3-hour test, you'd be getting home at 4 p.m. If you'd like to do that. Yeah, I'm not feeling too good. Okay. All right. People still use 4chan. So this is an exponential growth problem. It's not really zooming. So our model looks like this for exponential growth. 1 plus or minus the rate to the t power. So in this case, the principal is 2,500. Okay, this is going to be adding, not 2.4. Okay, what is it important that we do to that percent? We move it over twice and it becomes 0.024. And we don't even need a calculator, it's just going to be 1.024. And if we want to evaluate it after 8 years, our variable would be 8. Be careful when you type these in. And what does it say? Nearest cent. It's basically saying nearest hundredth, but for money. 1.024 to the 8th times 2,500. That's going to be 3,022.31. Thing to be careful of with exponential growth and decay, percents, making them decimals, spotting out what the percent of decay or growth is. If I have this, can anyone tell me what the percent of decay is? What percent is this decaying by each year? We move it 2 places to the left because you're dividing by 100. A percent means over 100. And yes, this would be 14% decay. This is like, a 5th or 6th grade topic. Percent, this right here, is saying out of 100. Dividing by hundreds, multiplying by tens, multiplying by hundreds just involves moving decimal places left or right. When you divide, you move it to the left. When you multiply, you move it to the right. We move it 2 to the left because we have 2 zeros. Let's try this. So we're going to solve this for x. This is a rearranging formulas. Systems, we'll try in a sec, but this is a rearranging formulas and it says solve for x. So notice here that I have x in 2 positions. So if I get them on the same side, it kind of gets me going. Anyone know what the next move is here? I can't, obviously, if it said 8x minus 3x, I could do that, but I can't do the math here. Anyone know what I can do at this stage? I can't divide by x because, yeah, that would help me over here, but then I'm going to have a divide by x. Factor, very good, Tiffany. I'm going to factor with GCF. Factoring is going to help because it's going to take me from 2 x's to 1. All right, we all agree I could do that, and now I have exactly what I want. I only have 1 x there. So I'm going to divide both sides by a minus b, and I get my answer. I've seen this a few times, I should say. Of a rearranging formula where it appeared, the variable that you wanted to be alone appeared in multiple spots. That's usually a sign that you should be using GCF to factor. I don't know how long this is going for. I have to eat dinner. It's like 9 o'clock. Yeah. Let's do like 2 more. All right, so let's check this out. So can anyone tell me, just by looking at the choices, just by looking at the choices, what does this tell us about this quadratic? Is this going to be factorable? It's not factorable. Very good. So what are our options in terms of how we solve this? Not ideal, but using the calculator would just give us decimals. We want the actual radicals. So we could do CTS or quad formula. Okay, so try this. I would probably do CTS. It's set up nicely for CTS. Quad formula, you're going to have to get rid of the denominator or simplify the radical. CTS, you don't have to do any simplifying. So, quad formula always work. You got it right on your reference sheet. Like I said, set up nicely for CTS. The magic number here would be half of 6 squared, which is 9. That's going to make that 28. This is now x minus 3. Yeah, I get like allergies in the morning and at night. This is going to be x minus 3 equals plus and minus 28. Move the 3 over. Okay, I can simplify, let's see, yeah, they did. I can simplify 28 to 7 times 4, with the 4 becoming obviously just 2. Radical 4 becomes 2. So I'm looking at choice. Be careful here, 1. Very good. Rational tangles. We are still learning after the Regents. You guys are going to be in geometry next year. Get ready for geometry. My goal is Wednesday. You guys have Earth Science Thursday. I know, not that we're going to review for Earth Science together, but we'll kind of talk about the Regents itself. It's not like the state test where it's like super secretive. You know, once the test is over, they don't really care anymore. So I could literally have like a test booklet on me. We could go over some things. I'll actually know your multiple choice answers right away tomorrow. So I'm not allowed to tell you guys, but technically tomorrow afternoon, I'll kind of like what I did for the mock, I'll know what you got out of 24, or I should say 48. But out of the 24 questions, I'll know, you know, how many people got 24s, how many people got 23s. I expect a lot of 24s. I'll know that tomorrow. I can't tell you that information, but we'll talk about the test Wednesday. So try your best to try to remember what you put, I guess, and we can kind of talk about those answers on Wednesday. When are you going to find out your scores? They send out the tests, so whenever that site sends them back, teachers from other schools grade ours. They send it to not like 74, but they send it to like Western Queens somewhere. He's eating over there. Why is this saying? Like what? Hold on here, my phone was bugging out. Yeah, I'm also filming this on my phone. My laptop wouldn't work. After the Regents, like I said, Wednesday, there's a lot of days, believe it or not, that we're off Friday. Thursday, you're taking the Earth Science. Wednesday, we're just going to talk about the algebra. Like, hey, how did you guys do? What did you think of this question? Yeah, you know, we can relax here or there. I want to do a day or two at least of prepping you for geometry, getting you guys ready for next year. Flatland 2 we'll watch one day, definitely, yeah. All right, and let's try one last one. There is a flatland sequel. Despacito too. Yeah, why does it say admin next to your name? He's eating really loud, that's the noise. You can't zoom. All he does is eat. Do I seem like an Eileen? Okay, let's add another element here of like when was the maximum height. This is, we'll make this the last one. Max. And obviously how long it takes to hit the ground we'll do as well. Yeah, this is a pretty accurate question. Mr. Royce says Despacito, so American. Parentheses, not racist. I've been here since the beginning. All right, so let's start with the maximum. Let's say we want to show our work for this. Okay, maximum, we're talking about 5 point something, not really an answer. We want to show some work. So with maximum, we're dealing with the vertex. If we want to find the vertex, the formula we would start with would be negative b over 2a. Excuse me. This is t. We don't have any x's here. Okay, so in this case, I'm going to do negative 40 over negative 16. Where did I get 16? A was negative 8. If I multiply it by 2, that's 16. 16 goes into 40. Obviously, it's going to be positive. It's time. Negative divided by negative. And that's what? 2.5? Now, what does that mean? 2.5 seconds, it's reaching the maximum height. This is basically our quote-unquote x value of the vertex. We'd have to evaluate that to figure out what the corresponding output is. What's the h of t? Can anyone help us out? So what is the actual maximum height? $53. Just double check. Two and a half, 53. Very good, Tiffany. Okay, so now be careful once again. These usually like to say in context. So what does this mean in context? That doesn't mean x equals 2.5. Context means add some like, talk like a human. Hey, at 2.5 seconds, it reaches a maximum height of 53 feet. Okay, obviously here, if we analyze this a little bit further, this is starting from 3 feet off the ground. Obviously, if she's throwing a ball, right, we don't like start, it's on a bowling ball that you put your hand on the ground and throw it. So she was probably throwing it from around 3 feet in the air. She threw it pretty high, got 53 feet in the air, maybe like a baseball. And now we want to find when does it hit the ground to the nearest tenth. So what does the fact that it says nearest tenth tell us? Obviously, with these word problems, this is not going to be factorable, unfortunately. So we got our, it does say algebraically, which means I only see like one thing pop up at a time, so that's why I'm just calling out like certain people's answers. I don't see the whole chat board. It says algebraically, which basically takes away our calculator usage. So, what options do we have to solve this? This is the other cat. What are you doing, bro? We could do CTS. I would definitely not recommend it here. In this case, I would do quad formula. So I'm going to say A equals -8, B equals 40, and C equals 3. Why would we not want to do CTS here? Why would we not want to do CTS? Can anyone answer that? Why quad formula, though? A is greater than 1. Very good. You're going to divide it out. It's going to be very messy. Very, very messy. Because I said so. Yeah, that's a good reason. Now, negative b plus or minus the square root all over 2a. It's going to be negative 16. B squared is going to be 1600, right? Minus 4ac. So we got 1600 minus 4 times a times c. I like to figure out what the radicand is first. And the good thing with nearest tenth, we don't have to worry about simplifying the radical at least. As we can see here, it's going to be quite large, but we don't really care what it even simplifies out to. So that works out to 1696. Kind of sounds like it would be perfect, but it's not. Okay, and now we want to do, we're actually going to do just the -1. So all we have to evaluate is negative 40 minus 1696 all over negative 16. Why am I saying just do the -1? Obviously there's two answers, but one of them is going to be a reject. If we add 1696, it's going to be positive in the numerator, negative in the denominator, which would be a negative t value. So I actually want to create a negative in the numerator, so I get that nice double negative taking place. This would be 5. What did I say? Nearest 10th. 5.0739 or 5.1 seconds. Yeah, we'll go over that quick. Someone just asked. It's kind of common sense stuff, but I've seen this asked like once or twice. Okay, that's a bad example. So, what degree is this equation? What degree is this equation? This is a third degree equation. Basically means what is the highest exponent? What's the lead coefficient? Lead coefficient would just be 4. Lead coefficient means when it's in standard form, what's the, basically like what's the very first thing you see when it's in standard form? Sometimes they might rearrange things and put like 5x squared up front. It wouldn't be 5. It's when it's written correctly in standard form. What's that number out? Way to show up on time, bud. Just like your attendance. Systems. We'll do one systems, then I gotta call it quits. I got you, bro. Auditorium at 8 a.m. Yeah. Oh. All right. desk. 1 sec. All right, someone asked for a system. I don't know. System. All right, so let's check this out. Giselle. Wrong class, Giselle. So I guess just here, whoever asked. Spread means standard deviation. Whoever asked this, for your just generic system, I guess, whoever wanted this would be elimination method. I wouldn't want to use substitution. This is also a double elimination. I got to multiply both of the equations by something. So I'm going to make this one positive 10 and this one negative 10. So obviously I'm trying to eliminate the y's. If you can't find the LCM, there's like one example I know on 37, I think from the January 2017, where it was like really large numbers and it might be hard to find like, hey, what's the LCM? You could literally just multiply the two numbers together. It doesn't matter if it's an LCM, a CM will also suffice. Lower SX is more consistent. I don't know what that means. SX just is standard deviation. There's like a sigma that's population, standard deviation. They're two totally different things. You're always going to use S of X. Okay, I could add these together. I'll get 11x equals negative 55. I'm going to get x equals negative 5. Now what do I do at this stage? Yeah, you could use matrices as well. Now at this stage you would do what? Plug in a negative 5 for x right here. Doesn't matter which one. Name 5 people. I think we're gonna. So the answer to this would be negative 5, 3. Name 5 people in both classes you think you're gonna 100. It's probably more than 5 people in both classes. I could name a lot of people. All right, so I'm going to call it quits in a moment. If you're coming tomorrow, we're going to do very similar to this and just kind of go over practice questions. Some last minute things for tomorrow. Most people, I assume, are coming at 8 a.m. They filled out the Google form. I haven't checked since this afternoon, but maybe more. It's already over my room capacity, and my room's set up for the Regents anyway, so I don't even have my smartboard or, the desks are facing like the test type stuff, test rows. So we're going to be in the auditorium. So everyone tomorrow, regardless of when you're coming, auditorium. Okay, 8 a.m. I'll probably stand by like the front doors over there just to remind people. If you're coming at 10:30ish, you're going to be walking in with a bunch of people, 8th graders, obviously. You might not recognize them, but every 8th grader is taking the algebra, except for the 8th grade magnet. They're coming at the latest 10:30. I would say get there by 10:30. People might be moving already. Mr. Anello might already say like, hey, go here, go here. So you don't want to be rushing and stressed out. Get there a little early. Get there around 10 otherwise. Some people said they can't make it at 8. they're coming in between, you know, to get like an hour of review, that's fine. We'll be in the auditorium. Okay, bring pencils, pens, eat something before, get a good night's sleep, go to sleep like right now. Look over the last few things. And hopefully you guys got a lot of stuff out of this. All right. So I'll see you guys all tomorrow. Best of luck as you finish studying tonight. Have a great night and take care. Mookie's sleeping somewhere probably. Bye.